I'll talk today about multimodal topic inferencing from a video. A recent feature we introduced into Video Indexer, a product we implemented from scratch here at Microsoft ILDC. The project handled, that's the UI of Video Indexer. Here we can see that facial recognition applied and other different insight as a one-stop shop for media companies to analyze their huge data sets. Here we can see Satya Nadella talks in the Build conference keynote of about 3.5 hours long about different concepts which are available here on the topics pane. Here we can see cloud computing, machine learning, technology, Microsoft of course, and different topics introduced into the timeline on the block markers here. They were captured using speech recognition, OCR, facial recognition for celebrities, and we're going to develop more in the future. So a bit more about the problem. We are targeting different media companies, as I mentioned before, to use Video Indexer as a trigger for cloud computing and empowering them to really understand their data and find the exact places in the video where Donald Trump discussed a specific topic in a particular emotion and many other search capabilities. This would allow them to monetize their data better, apply content moderation and different use cases. The problem is, of course, these companies usually have tons of data which is hard for them to build their R&D, and therefore they're using mainly human annotation in order to categorize their data better and apply content detection. So this is some graph I like to show about the under the hood in Video Indexer. Here you can see on the left-hand side a video uploaded and processed all the way through different machine learning algorithms, all the way to the video insights on the right-hand side. On the top channel, you can see the audio analysis with basic language understanding capabilities, as well as the visual channel below with OCR, face detection, grouping, and other capabilities like object detection and others. Today, we're going to talk about the model on the far right-hand side, which takes as an input different capabilities of transcription, OCR, and facial recognition in order to do a higher level classification of topics. More specifically, our input involves facial recognition using 1 million celebrities developed in Microsoft Research, optical character recognition applied both in Microsoft Research and Media AI, and speech-to-text services by Microsoft again. So we're kind of standing on the shoulders of giants to build higher level capabilities. I'm going to go through the pipeline of computation that we've done using a simple example of Stephen Bay, which was the manager of Edward Snowden. And it is a 45 minutes keynote in a technical session about cyber defense for tech companies. And so this is a Wikipedia page of Edward Snowden. As you all know, there's a bunch of text describing the entity itself, the Wikipedia page. And at the far bottom, you can see categories which were annotated by editors. And the basic hypothesis of the model is that we can use the knowledge graph of Wikipedia and these particular categories in order to use them as the terms that identifies the topic in a great sense. And here we can see a couple of examples. One is living people, which won't be great as a topic name for Edward Snowden in a context, but NSA people might be a better one. And we will try to, I'll show you how we rank those examples or candidates in order to pick the best topics per particular video. So after taking the transcript in OCR, we still need to capture the terms that were mentioned within. So if I'll take the speech to text from that particular video, we can see that a sentence by Stephen was the intelligence collection that the NSA gathers, the data itself isn't the most sensitive aspect to it. It's how we get the data, and that's what Snowden revealed. And here, by solving the named entity recognition in the context, we've been able to capture NSA and Snowden, which is Edward Snowden, of course, and get the context better. This is using Alice, another Microsoft service. Another example show you how multimodality could be great in that sense, and the phishing versus the cyber phishing is something that is noisy and we still need to handle given the larger context of both the visual and audio channel. So later in the pipeline, we fetched the Wikipedia pages of each and every entity, including the celebrity recognized in the video, which were mapped into their Wikipedia ID. And we built this similarity graph where we use TF-IDF cosine similarity as the metric between different entities where nodes illustrate Wikipedia page that were recognized, and the edges were the similarities. And using modularity maximization, which is a greedy and simplistic clustering algorithm in a graph, we've been able to both determine the number of topics or themes within the video and categorize the different examples into more meaningful concepts. Later, we applied PCA whitening and random forests as part of a ranker in order to pick the best category of or per particular cluster, which describes the topic in the best sense using features like the cluster diameter or the measures of centrality within the graph of per particular entity, or even in the category level using different NLP features. And so finally we're taking, that was, by the way, the only supervised part of the project. And later on we'll mark the different detection point on the timeline in which it was mentioned. So, as I mentioned, this video handles what happened in the NSA with Edward Snowden and what his manager thinks about how it could be used in order to better understand what will need to be done in the cyber domain in order to do a better job with tech companies. And so in this particular graph, you can see that we have a purple cluster talking about tech and cyber with items like malware, information technology. The orange cluster talks more about military intelligence like FBI, CIA, NSA, and different intelligence organizations. And the green cluster is simply irrelevant with lost TV series as another false positives that got here. But since we are capturing the geometry of the graphs, we've been able to capture the following topics, which were cyber warfare, cryptography, espionage, and government agencies. And so this is like how we filter out false positives during the inference in the pipeline. Another example for that is the following video, where Michio Kaku, a professor of physics, talks about the universe in a nutshell, and here the green cluster talks about the particle level elements, the blue cluster talks about astrophysics with items like Big Bang. The orange cluster is a classical physics cluster with items like gravity, force, etc. And the pink cluster is yet again another irrelevant cluster where, and it's mentioned also in the literature, that modularity maximization tend to pick one cluster that is a garbage cluster and put stuff that are irrelevant. Usually it would look more spread out. And so using features like graph diameter on that particular cluster can essentially deprioritize them. And as you can see here, none of the topics were picked from that purple cluster, but physics, of course, did. So Working with 1.7 million different Wikipedia categories is a large set, and to evaluate it, we use two different metrics. The first is the precision at 1. That would be the most significant topic, and for that we're on 95.2%, where general precision, given a larger set of examples per video, it reduces, and we are having different thoughts of where to take it next. So to summarize, the solution has been able to be robust using multi-channel analysis, and we've been able to reduce the problem using the Wikipedia knowledge graph, which also is self-maintained using periodic dump update, and the model is also interpretable in terms of detection on the timeline. Thank you so much.